One quote that I like a lot when I think about Bitcoin, we can attribute this to Jude Nelson, who's one of the core engineers that works on the Stacks blockchain, is that Bitcoin is not a waste of energy, it's just underutilized. So one of the big arguments we hear against Bitcoin is this energy usage. But when you look at it myopically like that and just focus on this single issue of energy usage, you lose a ton of context. So if Bitcoin is useless, then the energy argument makes sense. We don't want to waste that energy on something that's useless. But if Bitcoin is functioning both as a global, immutable, secure, hard money layer and as a global, secure, immutable, hard settlement layer for smart contracts, then that energy usage all of a sudden starts to look different. There are lots of things right now that use more energy than Bitcoin, and we don't bat an eye because we understand that they are valuable things. So that's kind of the key that comes in there, is this unlocks additional functionality for Bitcoin, again, increasing its value without actually having to modify the chain itself. So the way that proof of transfer works is you take this Bitcoin, you spend it, you send it to a specified address, and then that puts you in this weighted verifiable random function. So the more Bitcoin you spend, the higher likelihood you have of being the newly elected leader and being able to mine the next block. So let's say you win and you get to mine the next block, then you get rewarded with that newly minted stacks. But where's that Bitcoin go? The Bitcoin gets transferred over to stackers, as you can see here on the right. A lot of people get hung up a little bit here. So the stackers, this is not proof of stake. The stackers have no influence on the consensus mechanism of the Stacks network. That is all in the proof of transfer process, the transferring of the Bitcoin and the leader election there. The stackers are a little bit of a separate process where it incentivizes people to lock up their stacks in the network in order for them to earn a reward in Bitcoin, which increases the economic security of the chain. So it's not contributing to the consensus of the chain at all. It's adding to the economic security of the chain, which has network effects, because the more value that's locked up in a chain, the more attractive it is to people. And then two, it also has a secondary effect of being a signal to new miners that want to see what the real Stacks chain is. Let's say hypothetically somebody tried to fraudulently create a new Stacks chain, but there was no stacks locked up on their network, whereas there are tens of millions of stacks locked up on the actual Stacks network, hypothetically. That's a good signal to them, okay, this is the real chain. So it kind of contributes to security in those two ways. And so the big unlock that this gets us is it lets us build a financial system and economy trustlessly without anybody actually having to use the Stacks network, because the final thing that we get as a result of this and as a result of the Clarity language is that we get visibility, read access into the Bitcoin chain. And the second part of that that's being worked on right now, that will be the next step into that, is write access to the Bitcoin chain. So eventually what this will allow us to do is we can monitor a certain Bitcoin address for certain activity in our Clarity smart contract. We can take some action on the Clarity smart contract network, do what we need to do on that side, handle the complexity of the smart contract, and then we can take another action on the other end of that on the Bitcoin network. That's sort of the big picture unlock. We're not quite there yet. There's still some work to be done to unlock that write access on the Bitcoin chain. But high level, that's what it's going to allow us to do. And again, I want to hammer this point. It's going to allow us to do that without affecting the underlying money and settlement layer at all.